we go. You are conducting a study to see if the proportion of voters who prefer the Democratic candidate is significantly larger than 79% at the level significance 0.05. According to your sample, 80 out of 95 potential voters prefer the Democratic candidate. All right. So for this study, you should use, again, it's the same thing, z-test for p proportion. For p proportion, because it says proportion right there. They're given percentages, right? Next, the null. Okay, remember what we have to do before we do any of that other stuff? We've got to write the claim, right? So what is being claimed? You see it in there? You're trying to see if the proportion is larger than 79%. You see, that's what you're studying. Larger than 79%. Larger than 79%. So that means I've got to write P greater than 0.79. So the P is on the wide mouth side. It's greater. It's greater. Okay. So this question number 4 is the same as number 3. It's just different words. It's all the same. So I'm going to now, what is HO always? HO is always equal, right? Always equals 0.79. And H1, what's H1 going to be? Well, remember, one of these two has to take the claim. One of them must be the claim. One of them must be the claim. Well, it's not HO because HO is equals and this isn't equals. So therefore, it's H1.
It'll be greater than?
Exactly. It's got to be exactly the same as the claim. One of those two must always be exactly the same as the claim. Does everybody hear me on that? That'll really help you to have that really solid in your mind. One of those two is making the claim. That's the whole point. We're making a claim and we're testing to see whether it's true or false. So either HO or H1 has to match the claim. One of those two will be identical to the claim. One of those two. And the HO is always equal, right? HO is always equal. So the only time HO will be the claim is when the claim is equals. Then it'll be the same as HO. But when HO is, when the claim is not equals, then it's H1. All right, so one of those two is always the claim. HO is always equals, so the claim had to be H1. All right, so that'll really help you. If you get really clear on that, one of those two always must be identical to the claim, and HO is always equal. All right, on we go. The test statistic, that's going to be our Z value. Let's go to the calculator. How do we go to the calculator on this one? Well, we're going to go there. We're going to hit stat. Go over to the tests. Go down to the one prop Z test. And hit enter. It's on number 5. And then it'll give you some options. It'll say P0, X, in, and the proportion. Okay, so what's your P0? Same number as H0. That's what that 0 is supposed to remind you. Just go, oh, right there, 0.79 for my case, whatever's next to H0. Right there. 0.79. What's X? The number asked for, and N is the total number. So what's the number being asked for? Well, it said that 80 out of 95. 80 out of 95. There it is. On my example, this will be 80, this is 95, and the prop is the same as H1. What's H1? My H1 is greater. That H1 is greater. So then that will be greater. And then hit the buttons on your calculator. I'll put that in myself. And I'm getting the following. I'm getting Z is 1.24686. P is 0.106223. So let me show you that on the calculator. Here this. Okay, so I hit stat, go over to test, down to one prop Z test, hit enter, my P0, I'm going to put in the new P0 here, which is 0.79, right, for me anyway. Go down to my X is 80, my N is 95. And I'm going to go down. Mine's greater. My H1 is greater. Go over to greater. Hit enter. Got to highlight the greater. Now that's highlighted now. Go down and hit enter. And there it is. There's the numbers I was telling you. Z is 1.24686. There's my p-value. Got those. Let's go back to the iPad here. There we go. All right, so we got those values. So now we're ready to draw a conclusion. What is my conclusion gonna be to this study? Well, the conclusion is gonna be, so it's all about the P. So what does it say to here? My Z number, they want 3 decimals. So my Z number is 1.247, round 3. The p-value came out to, they want 4.1062. And then here's the question, is the p-value, that 1062, what's my alpha? My alpha is 0.05. So is this p-value, 0.10, greater or smaller than my alpha? That one's greater, isn't it? 0.10 is greater than 0.05. So it's greater. So my p-value is greater. So P is greater. Now remember what that means. P is greater. So you can go to the notes. But basically, you can look at the notes, but I'll just write it out for you right here. If P is low, then HO must go away, right? But my P is not low, right? P greater, P not low. To be greater is to not be low. So if so let me go back here. If P is not low, then HO must not go away. You just throw a not on both of those. So if because my P is greater, My p-value came out greater. My 0.10 p-value is greater than my alpha 0.05. So that is saying they're wanting me to test it at the 5% level. My p is greater. It's not low. So if the p is not low, then the null must not go away, which means if it doesn't go away, what does that mean? So I fail to reject. I fail to reject the null. I'm keeping the null. It does not go away. I don't reject it. I fail to reject it. So that's what we put right here. Fail to reject it. In other words, you're going to keep the null. Does that make sense? We're keeping the null. Keep the null. Now remember what that means as far as evidence. There's always weak evidence for the null. That's like the assumption in the court of law, assume innocent. And there's strong evidence for the H1. We are deciding to go with HO. We're keeping HO. Evidence is weak. We're keeping it. What does that mean? Let's go through the options. The data suggests the population proportion is not significantly larger. Right, it's not. We're concluding it's equal, right? We're concluding P equals. So there is sufficient evidence? No. There's weak. Weak means not sufficient. Maybe I should write that. Weak means not sufficient. There's not enough evidence. There's not sufficient evidence. It's weak. Let's check it out. Yeah, it looks like this. The data suggests it's not significantly larger. Right, it's not. So there is not sufficient evidence. Right. That's our conclusion. Right there. Right? It's not significantly larger. Right? We conclude it's equal. It's not sufficient evidence. Now it has us come down and make some other conclusions. Let me move these out of the way and we'll draw these other conclusions. What does it say? Interpret the p-value. What does the p-value mean? So I haven't mentioned this yet. Let me now mention for you what a p-value means. A p-value is the percentage chance. It's the percentage chance of an error. Let's see. Or no, I'm sorry, not of an error. So what did our p-value come out to be? 0.1062, right? That's our p-value right there. P-value is, mine came out 1062. So I got a p, 0.1062, which is 10.62%, isn't it? So what does that mean? There is a 10.62% chance that more than 79% of all voters prefer the Democratic candidate. No, that's not what it means. 10.60% chance that more. No, it's the percentage chance that the results were just an error. Let's see. If the population proportion of voters who prefer the Democratic candidate is 79%, and if another 95 voters surveyed, then there would be a 10.62% chance that more than 84% of the voters, more than 84%? No, not 79. Let's look at the last one. If the sample proportion of voters is if it's really 84, well, this is kind of confusing, isn't it? Oh boy. Let me read this carefully here. So it's saying if the sample is really 84, what did it come out to be for us? if the population you prefer is really 79%, and if another 95 votes, there would be a chance that more than 84% of the voters. Yeah, it's that one. Sorry, this is tricky. It's this one right here. And what is this 84%? Well, that's the percentage 80 out of 95. If you take 80 divided by 95, that's what they're saying. That's what the p-value means. That's the meaning of the p-value. It's the percentage chance that you would get these results, assuming the null is true. So I know that's probably tricky here at the after we've talked about so many other things. I know this is a little tricky. This will make more sense over time. So let me write that out for you. What is the meaning of a p-value? P-value, it's the percent chance of getting, let me start with assuming HO is true, assuming the null is true, it's percent chance of getting these lucky, or these results by luck. Percent chance of getting these results by luck. That's what a p-value really means. P is the percent chance of luck. Think about it that way. P is the percent chance of luck, assuming HO is really true. That's what a p-value is, the percent chance of luck. Percent chance of getting these lucky results, assuming the null is really true. So that's what they said here. They said if the population of voters who prefer is really 79, that's what the null says, right? The null says it's equal to 79. And then for having 95 voters come out 84%, that's a 10.62% chance. Exactly, that's what a p-value is. Finally, last part here, this last little part that we have. What's it say? Interpret the level of significance in study. So, in the context of study, there is a 5%. What's the level of significance? That's the alpha level. So that's right up here. That's the alpha 0.05. Alpha 0.05. So significance level is the alpha is the 0.05 or 5% on mine. So what are they saying? There's a 5% chance that the proportion of voters who prefer the candidate is, no, there's a 5% chance that the earth is flat. No. If the population proportion of voters who prefer the Democratic candidate is 79%, that which is what the null says, and if another 95 voters, there would be a 95% chance that they would end up falsely concluding that the proportion of voters who prefer the Democratic is larger than 79. Yeah, that's what it is. It's the chance of falsely concluding H1. That's what it is. What does that last one say? If the proportion of voters who prefer the Democrat is larger than 79, no. It's is 79. It's the null. You assume the null. Is 79 the null? So let me write it out for you. Significance level alpha, which is often 0.05 or 5%. I'll just say it's often not. It's not always. What does it mean? It means, again, assuming the null is true, it's the percent chance of wrongly rejecting the null and going with H1 by mistake. So like in a court of law, it's the chance of a guilty verdict when the person is really innocent. So that's the significance level. That's what they're testing there on that one. And so that's why I conclude what I concluded there.